Right, so this lesson's on reflections in the equation of a specific line. So before we start with the reflections part of things, we're just going to recap over what all the different lines look like. So for your starter, on some rough paper, could you draw each of these 4 graphs and then come back and check it? So pause it now and have a go. Right, so the first one is the line y equals 3. So that means it's got to go horizontally through the y-axis, crossing at the number 3. Number 2 here is the line y equals x. So that's when every y coordinate equals the x coordinate. So for example, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. And if x is 0, y is 0. So it forms this long diagonal line, like so. Number 3 is the sketch of the graph y equals minus x. So that's very, very similar to y equals x. It's just the opposite gradient because it's now got a negative gradient like this, again going through the origin 0, 0. Finally, we're asked to draw x equals minus 2. So that's got to go through the x-axis, vertically crossing at minus 2. And there we have it. Gets us to here. Okay, so for our first question here, we're asked to reflect the triangle in the line y equals 5. So we're going to start by drawing the mirror line on. The line y equals 5 has to go through the y-axis, crossing at the number 5. So that's exactly where our line's going to go. So there's y equals 5, and then we're reflecting and using that as the mirror line. So this point here, because it's on the mirror line, is going to remain still. We call that point invariant because it hasn't moved. We've then got another point down here, which is 1, 2, 3, 4 away from the mirror line. So we need to go 1, 2, 3, 4 the other side of the mirror line, its new position. And then we've also got this final corner here, which we need to go 4 up again. So there we go, there's our final image all connected up. Okay, so this time we're reflecting the triangle in the line y equals minus x plus 9. So y equals minus x we know has a negative gradient going this way. It would be going through the origin here if it was just y equals minus x, but because it's plus 9, it starts at the 9 and then comes down. You could, if you wanted to, if you weren't sure where this line went, you could draw a table of values. So if we have x is 0, maybe x is 4, and perhaps x is 8, and then we'll sub each of these x values into the equation. So y is going to be minus 0, so just 0 plus 9, so that gives me the first y value. Then if x is 4, y is minus 4 plus 9, and minus 4 plus 9 is 5. And finally, if x is 8, minus 8 plus 9, which is 1. So 0, 9 is here, 4, 5 is here, and 8, 1 is there. And then we can connect those up to form our mirror line. Okay, so now we're ready to reflect in our mirror line, and we're always looking perpendicular to the mirror line to count our distances. So here, for this top point, that's our perpendicular direction. So that's 90 degrees just here. We've got another point down here and going perpendicular to the line. There's our right angle, and here's the final point going perpendicular, there's the right angle. Okay, so back up to the green one, we're going 1 box diagonally, so we're going to go 1 box diagonally the other side. Then for the red, we're going to go 1, 2, 3 boxes diagonally. So then it's 3 boxes diagonally out the other side. The blue point is 2 diagonally, so that finishes here. And then we just need to connect up those 3 points to form the shape. So there we have our completed image. Okay, in example 3 here then, we're reflecting in the line y equals x. So that's the one that we drew right in the beginning of the starter, where everything has got the same x and y value. So it goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. So a nice straight line connecting those. So that's our mirror line, and then we're looking at each of the points again. So if we start with this red point up here, it's diagonally half a box, so that ends up diagonally half a box the other side, acting perpendicular to the mirror line. If we then try this point down here, looking at the distance, it's 1, 2 and a half, so a half, 1, 2 out the other side gets us to there. And the final point is 1, 2, 3 and a half, so a half, 1, 2, 3 gets us to there. And then we connect up the lines. It's always quite good at this point just to check that the shape hasn't changed in its size at all. Okay, and there we have our finished image. This final example is asking us to describe the transformation, and we know it's a reflection because the shape, it hasn't changed size, so it's not an enlargement, but it's literally been flipped across the other way. So all we've got to do here is find where the mirror line would be. So if we look at the fact that there's 4 spaces between here, the mirror line must be right in the middle there. So this suggests that the mirror line lies along that red line there, and then we've got to just use our algebra skills in order to describe it. So it's a reflection in the line, and then this line is a vertical line crossing through the x-axis at 6, so the equation of that line is x equals 6.